All right. So this is a sorting interview, is that right?
I don't know because I think they have a job done. Originally, I was trying to pick maybe a coding interview because I want to have virtual on-site with Meta. And according to them, they said that they have two round coding interviews. Each round, I think I'm supposed to solve two coding questions. But I think on the job done from the mock interview, we actually have all coding categorized. We have like sorting, we have dynamic programming, we have graph, we have tree. So I guess, yeah, that's why I said, okay. And also according to the recruiter, the sorting and the string would always be tested there.
Okay. All right. That sounds good. I do have sorting questions for you. And
Okay.
the way it usually works is the first one will be an easy question.
Uh-huh.
And if you can get through that pretty quickly and have it coded up, then I'll ask a second question, which will require some more problem solving skills.
Okay.
And so that's, if we only get through one question, then it's maybe at the bar performance.
Okay.
I don't know if that would be enough to get you into a place like Meta. But if you answer two,
okay,
then you'll be fine.
Meta, I think it's a good practice because they do have a very systematic, organized MLE interview. So
that sounds good.
Okay, thanks.
All right.
So I have a code pad. You share the link, and you should be able to see me typing, right? I have to share screen.
Yeah, if you want to share your screen, that would keep a record of it for you. All right, I've got your first question here.
Okay.
There you go.
So given an array of an element where each element is at most k from its target, away from its target position, okay. Rising thought. Since the k is 2, an element at index 7 is the sorted. I don't quite get, can be index 5, 7. So input 6, 5, 3. So given an array of n elements when each element is at most k away, k index away from its target position, defines an algorithm result n log k, n log k time, for example, let us consider k is 2, an element at the index 7. Okay. So the input is array. It's partially sorted because each element could be at most k difference from its sorted index. And the input would be such an array, output would be, we get the k. We try to get the number k. Is that the output?
The output will be a sorted array.
Output would be sorted array. Okay, output would be, and we want to use algorithm that's n log k, because if we sort a typical array, it's n log n. That's a typical algorithm. So if we want to sort k, because okay, n log k, n log k. So that means and so if we n log k, this has something maybe to do with hips, the hip sort,
Okay.
n log k. Let me think about it. So if the first element is 6, if it's the first element and we know k, it can only be at a minus k or plus k. So so that maybe 2k plus 1 position. 2k plus 1 position. 2k plus 1 position. So if we get the window of 2k plus 1 and 2k plus 1. So for each, so basically for each index, we will have 2k plus 1 maximum, 2k plus 1 elements. Then these elements we want to put in the heap and then pop from the 2k plus 1 size the heap to this index. Then we move to the next index. Because the heap pop would be when we build a heap. I think it's if it's 2k plus 1, it would be k. It won't build a heap. The time complexity is O of k, right? If it's a size 2k plus 1, not log k. Not log k. So let me think if it's log k. So 2k plus 1, we look for, we started would be k log k. And this k. So we're moving this window sorted at 1, at 1, at 1. I think first we started the first 2k plus 1 elements. Actually, if, from 0, we only started the first k elements. After that, I think we got this, we wouldn't know where the first number should belong to. After that, we insert we add, but this would be a heap of size k. We popped out 1. Then we insert the second, insert the k plus 1s. We insert 1 by 1 to the heap, and pop the mini queue each. Actually, pop the mini queue each time, and that would be. Oh, this actually is not right. I think we need to go further. Cannot be k. So beginning is k. So 2k plus 1. So we need to first build I think basically we need to build the index. So for the first one, we go to k. Second one go to k plus 1. Then the third one, we need to also check. Do we need to go only one direction? Let me think. We keep going one direction. K plus 1. I still think we need to build the heap, the minimum heap with 2k plus 1 element, and each time we pop 1, and then we add 1 element. When we add 1 element, I think we first have the first 3, and we put 1 to the first one, and the other 2 can continue going. Maybe I can just build a heap of size k, and then each time I pop the root of the heap, put to the so I have a right. I think so I will go one by one from 0 to n. So each time my read pointer would be from k plus 1 to the last element, and my right pointer, whenever I pop back, I will write back to the right pointer after right pointer plus 1.
Okay. You wanna I think using a heap, you're going to be using the heap to populate the array. Is that right?
Yes, but I think the time complexity doesn't seem right, because we build the heap, we need O of k, and we need to build basically n heap, so it's n times k, not n log k. So the time complexity doesn't seem right.
Well, let's think about it. So how big is the? Let's try to visualize it. Maybe that'll help us.
Okay. So if the k is the 3, I built the first heap would be 3, 6, 5, and then I pop 3. But when I build 3, 6, 5, this heap size, so each time, actually, it is log k, because later on I insert, because I have the one, when I insert, the heap file takes log k.
Okay.
Okay, so I can write it.
All right.
So we have an input. I think it's I forgot the syntax.
What are you trying to do?
To build the first heap, I think they have heap queue push for sure. Let me just put it, because I don't know if they have, because they can build a heap based on a list. We can pass in a list to this.
If you're going to describe it as a verb, what are you doing to the list?
So first, I will build a heap with size of array 0 to k. I think it's called hip find.
Okay. I believe you.
So, hip find. I think the first step is 0 to k. So we have this amount, and we have the right, and we have this is left pointer, we have a right pointer equal to k, and so after this we have a q and ring L equal to its pop and L need to update probably need a loop while
Okay.
so this and we would push one to the hip. So then we do a hip push a new element. Right pointer one. And at the end, we still need the, because when we finish, we need the pop. So, maybe we should get the lens at the beginning, because I don't know if this would be changed. So we don't have to calculate this again. Something is not lined properly. Push. Some syntax error. One is smaller than n.
I think it just needs one extra space.
This one. So then we need a let me test it. I don't know if it's working. So,
I'm not going to run it, but let's walk through it.
okay. So first, I get the length of the array. Do I need, maybe I should also check if the k is bigger than, I will always have an invalid input.
Let's just assume we have valid input.
Okay. So then first I get the length of the array. And the first, because I always maintain the heap size to be k. So the first heap I build would be the first 3 elements. And after that, because in Python, this heap queue is a mini queue. So the element start in the root of the heap would be the smallest one. and then I pop it and write to the current left index. That's the one we're supposed to write. We're trying to, because for each index, after the sorting, we know the smaller, the ones before that, I think they're all sorted because this condition, they can only be k away from its target.
Okay. Can we walk in detail through the first example?
So first we have 6, 5, 3. Then we build a heap for 6, 5, and 3 because k 3. And also for oh, actually that's something wrong. So because the distance is k, so the 2 should be the smallest, cannot be 3. Because
so let's go into a bit more detail. So we have, what are the indexes for this? This is index 0, 1,
2, 3, 4, 5, 6.
Okay, so there's our indexes. And then k is
3, yes.
So if k is 3,
we need to go to k plus 1, yes, because
do we need to go to k plus? So with
the Python,
does it default k minus 1, or
default is k minus 1? Yes.
So is that true?
It's true because I can.
So you have to assume that in an array range
from 0 to n minus 1. And if I say if we can give a try array equal to, oh, how to try this one? 1, 2, 3, and the print ARR. If we go 0 to 2, we will have all of them. If
you do 0 to 1,
only 1, so it wouldn't have the index 1. It's excluded.
Interesting. Okay, that's wacky.
That's why this needs plus for sure. But
okay, good to know. I'm not a Python expert, by the way. I'm floored. I would assume that it would include the last one, but I guess not.
It didn't include last one, so we have to add this, and then the right one should be from this. And we cannot have n because it has to be less than n. This has to be less than n. Plus 1. So the first, we use this for to build a heap, and we got the smallest one. The heap pop would pop 2 out. Then the second time, we push this 8 inside this heap, and the 3 would be in the root. So I have 2, 3. Then the 10, then we would pop 5. Then 9, we would pop 6. Then I think the leftover, each time we pop something, it would always reorganize.
Okay. Oh, it looks like you made a few modifications while I wasn't looking there. All right.
I did, because I made all those edge wrong. Because you mentioned if this is included, then I realized Python is not included.
Okay, great. And you said R is less than n as opposed to less than or equal to. Okay. All right.
Because originally
that actually looks like it should work. Okay, so time complexity is n log k. Congratulations. What is your space complexity?
Because I need to build actual heap, so it's all of k plus this. Do I have anything? I use the original array space. So I think that's it. O of k.
Okay, perfect. All right. You did that pretty well.
But I think at the beginning I was choked because I wasn't very familiar with all the data structure classes. I took them like maybe 20 years ago. I thought, oh,
yeah.
heap. I thought, oh, I remember build a heap. It's O of n.
Yeah. The only thing I can find wrong with this is there's a typo for heapify.
Oh, how to maybe
there's an I there. I think it's
heapify.
Is that right?
I don't know. I used this at work once, but I know that's a heapify. I don't quite remember syntax. It's
and I think it's heap pop and heap push, if I'm not mistaken.
Yes, I think it's heap push.
Because I've done this question for a lot of Python folks, and they've used that syntax. But I would review that heap syntax very carefully.
Okay.
But that's the only weakness I can find in this. I think you solved it pretty well.
Okay.
All right. Good job. Do you want the second question?
Sure.
All right. Down at the bottom here.
So median is the middle value in an ordered integer list. If the size of the list is even, then it's the middle 2 divided by 2, I think. That's no middle value. Oh, this is middle. Because I actually have a majored in statistics. Median, I think it's the middle 2 value divided by 2. Oh, it is. Okay. There's no middle value, so the median is the mean of the two middle values. Okay, so otherwise it's the middle value. To design data structure that support the following two operations. Point data stream to the data structure. So this one. Because this one, I think we talked. I think we did the homework.
Oh, really?
I think so, because I think I also used some heap to sort it. I think it's in the homework. Do you want me to show you the homework? Because this one we did it. I think I also used the heap, but the details, I think the heap, because we need so it's the stream. Let me think about it. So it's the stream we always have to return. So if we have, so we always need to maintain the size of two heap. I think the first heap would be, so it's one would be probably max heap, one would be the minimum heap. Because the first one, I think we want, and we always try to make sure the size are balanced. So the two heaps size difference can only be one, either equal or one is bigger than only by one element. And then if it's equal sized, I think from the left heap, it's all the elements are supposed to be smaller. We pop because it's a maximum heap, and the second heap is the minimum heap. Then we pop from that heap, then divide by 2 when the size is same. Otherwise, if the size is not same, whoever has a bigger size, we just pop the element from that heap, return that value.
Okay. That sounds like a good strategy.
I think that's what we did already. I can show you.
Oh, well, let's see if you remember how to do it.
Oh, okay, that's fine. Let me see if I remember how to do it. Oops, where's the
pasting the right answer won't count.
That's true. I even couldn't find the window. Okay, so here, so we want to add So we need to build the design data. So the data structure, I think we will have two heaps. The one heap is the max heap. The other one is minimum heap. The add num. So we have add. The add would be check the size of the heap. First I think check the size of the heap, and also compare with the top value of both heaps, so we know if we need to probably switch elements sometime.
Okay. Do you want to start coding it out if you already feel comfortable with your approach?
Yes. So the data structure, I think would be. I think we still use. No, it's not that. It's heap here. And we will have two sides, so we have left max heap. Let's left empty and then so the add one, none would be, because we will have so we wouldn't know the max size heap queue. So, instead of pop, yeah, I think I know. So because it's a heap queue, so it's the first element. So if n smaller or equal to, if it's equal, we also can have elements equal, right?
Maybe.
Okay, here I think we have to check the size. So if the size is not balanced already, we have to shuffle. So so we have two things. I think balanced case. If it keeps balanced, then we only need to figure out where this new integer needs to go to which queue. Balanced case. Why this thing is so weird? If let's say we only need to find the place, so we need to check if n smaller or equal to max heap, the first element, pop element, we don't pop, we keep there. If it's smaller here, if it's smaller than this, we go to the max queue. So insert into max queue. Insert. So here we do max. So you said it's hip push. Hip push n. else, I think it's we need to push to the mini heap, and so this is the balanced case. Otherwise, if it's not balanced, if left, so here, if this is bigger than this, so if this is bigger than this, if we insert to max Q, we need to do some shuffling. Insert to max heap. So otherwise, if it insert to the mini heap, then we don't have to do anything. So here, if n smaller than, so if it basically, if it's like this, if it's like this, we need to first pop the max, so max heap pop. That element needs to be inserted to the mini heap, heap push, and then we insert the max heap push, and if this else, we just push to the mini Q. Okay. And then we have the last mirror case. So we do else here. We just I have two if. So if and so else this, if this, then this one would be smaller than this. So this would be and then we have to put into the left side, left hip push, mini and push in. So this would be my add number. So to try to maintain those two hips, either exact same size or one has exact one element more element. And after that, the fund medium fund. So the fund median would be very straightforward because if the size is the same, then we pop from both heap and divide by 2. If the size are not the same, whoever has more element, we pop that from that heap and return. So then we will pop max So basically, that's the first element plus. That's my code.
Okay. Can you see any bugs in your code just on the outset?
Yeah, I'm reading. It's the same. Then we return max heap plus list divided by 2. If list, we return max heap, the first element. 0. Because this would eventually maybe object oriented, we probably have to put a self and all those things.
Maybe. What does the self refer to in this case?
I think the self, because eventually we have this data structure written in an object. And then we probably have a max heap, mini heap. We maintain this object. So when this stream object, we store them into 2 heaps.
So is the way you've written this, is this an object?
Now I didn't write the object. I didn't write the whole thing. Originally, it could be an object, could have a class.
Okay. That was the first thing I wanted to. All right. And let's walk through the very first example.
Okay.
So let's say we have an empty heap, 2 empty heaps. All right.
Oh, that's
and now
true.
we add a number.
So when it's both empty, then we cannot compare. Actually, if it's the empty, we just okay, that's a bug here. So so at the beginning, if it's 0, we actually can put anywhere. We just put into the first one. If then if that's 0, so we need to check. So here, insert list. I also have to check if maybe we just put outside because I think we don't have to break the code. So if both of them are empty, if max and max 0 and we can do any of them. So just because this we always have to compare. If it's so if 1 is not 0 already, if we go here, if it's bigger, so
Okay.
yeah, I think that should be fine.
All right, so I think there's a couple of little things in here, edge cases. what's the time and space complexity for each of your operations here?
So for each insertion, I think we would have log n.
Okay.
Log n, and for find the median would be O of, I think it's a constant O of 1.
Okay. All right. So the feedback on this one, I mean, you remembered what you learned in the class, but they were asking for data structure, and so I would make sure that that is created as such, so that how would you name it? How would you name the data structure? And because they give you the functions to use, but what are you building? How do you logically name it? There's also quite a few bugs in here.
Yes.
That will give you a null pointer exception.
Okay.
Yes. And so just be careful of that. So I would say for the second question, the feedback from the interviewer would be code was a little messy.
Okay.
and that might be enough to knock you out of the interview. You want it to be well written and well organized, and you also want to think of all your edge cases and your tests before you start coding.
Okay.
Yeah. So like, what happens when you enter that first empty set? What happens if you use these types of numbers? What happens? And then try to visualize the logic as well. Okay. But I think for the most part, this would work, minus the few bugs. So it'd be an almost, but not quite.
Okay.
So I'm gonna push you to do train a little more, and then also make sure that you know how to define a max heap, because it's a little bit different from a min heap. Right now, both of these are min heaps.
So they need to use the negative number. I think they did teach us the tricks in the classroom in Python, because Python only have everything. Python only has one implementation, that's the mini heap. So in order to accomplish the max heap, we have to multiply by -1, and then eventually when we get a real number, need to multiply by -1 again.
Okay.
Okay, yeah, I think that is also something I think in the class. I think when he showed the code, I totally forgot. Yeah, but I remember the most of the things from the class.
So are you sure there's no way to designate a max heap separately, so you're not adding or multiplying by -1?
I think in the classroom, definitely the teacher says there's no implementation of a max heap in Python, only the heap queue, that is the mini heap. So in order to accomplish the max heap implementation, you have to, the key, you have to multiply by -1 to accomplish that goal.
Okay. That's very strange. Okay.
Yes, I think that is something I think now when you brought that up, I remembered, yes.
Yeah. So yeah, brush up on your max and min heaps for Python.
Max min heaps. Okay.
In Java, it's called a priority queue, and it's a different. You have to pass in a comparator.
Okay, so you just
and it's a little easier.
Okay.
But yeah, I think why do I feel like that the way you do it in Python is a kind of a workaround, not an actual solution.
It is a workaround, yes. I think in the classroom he mentioned it's a workaround because he says in Java, he said it's a very clean code. In Python, it looks like it's hacked because you multiply by -1. When you do the find the median here, you need to multiply by -1 again.
Oh my gosh. Yeah, this is
yeah, because when you have this problem, I thought, oh, this was taught in the classroom. But this, I think, probably during the interview, I think it's like today, the response is not right. Because whenever I see this, I actually feel a little bit freeze while this is in the classroom.
Yeah. Interesting.
So when the interview, they ask me to something I thought before, I should pretend that nothing happened.
Yeah.
Okay.
Okay. So in the interview, you would say what?
So if in the real interview, if they ask me something like I saw in my practice or whatever, I shouldn't let them know, should I?
Oh yeah, no. Just say, you can say you've seen this before, but make sure you know how to solve it, because I've had people in interviews, they say, "Oh, this is easy." Like I gave them the first problem for a traversing a binary tree. For a trees coding question.
Okay.
And they said, "Oh, this is so easy. You just do this and that and you're done." I'm like, "Okay, implement the code." And I was expecting like 5 minutes of coding. He couldn't figure it out. He couldn't actually implement it. And that's where those things go wrong.
I see. Yeah.
Don't be overconfident and say this is easy and then turn around and struggle solving it.
No, I wouldn't say this is easy, because when I see this thing, I know like in the classroom, he was trying to solve it, and the code was pretty messy because he was also using Python.
Yeah. Okay. But I mean, I would say you're pretty close. I would say that, you've got some good communication skills and good problem solving skills. And I think just brush up on your heap implementations in Python.
Okay.
And then also make sure that your code looks like something you would write in an actual code base.
Okay.
Like when they're asking you to do this, they're seeing how well organized you are, and how do you name classes that do important functions.
Okay.
And so that's part of it. And once you started writing definitions, the function names first, without thinking about the class and what the class is doing, well, okay, those were asked for, but then what is the class? What is the data structure itself? What's in that data structure? I see. I see 2 min and max heaps, right? What else might they ask for in that? And so you're going to want to write it so that you can keep adding to it if you need to.
Okay. And also, because I think I don't even remember the syntax how to write Python class, because most of my work, data scientist work, I don't need to write class, because I do remember that's a class, then class name, then column, then probably def init or something, because I don't quite remember the syntax. I need to brush that up. Yes.
Okay. Yeah. Sounds good.
Okay. Thank you so much.
All right. Thank you. And good luck on your meta interview.
Thank you.
All right.
Bye-bye.
Bye-bye.